Now we are taking up into the consideration the third criteria, that is the proper ignition temperature. So the question comes, what does actually the ignition temperature means? So you will be surprised to know that any substance do not catch fire until or unless its ignition temperature is achieved. So what do I mean by saying this? So ignition temperature is actually a temperature at which substance catches fire, So some substances have higher ignition temperature and some substances have lower ignition temperature. As you must have come across many substances which catch fire very soon and which catch fire almost late. So that means there are certain substances whose ignition temperature is too high, that means they don't catch fire easily, and few substances are there which catch fire very soon. That means they have low ignition temperature. So we need a substance for the combustion which should have proper ignition temperature. That means the ignition temperature should not be so high and it should not be too low. It should have the proper ignition temperature. So any substance, so that means for burning we need three things: combustible, supporter of combustion and ignition temperature, and the ignition temperature should be moderate one. Moderate means neither too high nor too low, right? So one question is striking in my mind. Have you ever seen, or can you answer me this, that I have you can say few dry leaves and I have few wet leaves. So I want to just burn them, right? I want to burn those dry leaves also, as well I want to burn the wet leaves also. So what do you think that out of them, which is going to catch fire soon? Will they burn at will they catch fire at same time? Or they will you can say the dry leaves will catch faster or the wet leaves will catch faster. Any idea do you have? So just let me tell you that out of dry leaves and the wet leaves are going to burn late, and as compared the dry leaves will catch fire very soon. Now what is the reason behind? The reason behind is the ignition temperature. Because in wet leaves water is present and in dry leaves there is no water, no moisture, nothing is there. So the water which is present in the wet leaves is going to just increase the ignition temperature of the leaves. So what will happen? It will just increase the ignition temperature. That is why they will catch the fire. Obviously they are going to catch the fire, but they will not catch the fire so soon as the fire is catched by the dry leaves, because dry leaves are deprived of the moisture or a water content. So that means the ignition temperature actually is fallen down. So it will catch fire easily. So that means any substance which catch fire or you can say to burn any substance, we need a substance and we need to know its ignition temperature, because until that temperature is achieved, the substance won't catch fire, right? So this I think is clear to you, that what is burning actually, what kind of in which form we get the energy after burning, and what are the three conditions are required for the burning. I think it's clear now. So just I want to list few examples for you to show that what kind of oxides, like when some substances undergo oxidation, so what kind of you can say the substances they are forming. So I am taking into the consideration the metals first. Just to make easy, I am just writing the reactivity series so that we should know that what according to the reactivity, at what temperature they are forming the oxides and what are the formulas, and which metal do not form their oxides at any cost. So I am just listing few examples for you. So just look at, and I think you can easily recall that the reactivity series we did. So I am just writing again. I think you remember it. I told you in the previous topic how to remember this reactivity series. That was a funny song. I told you that Kedarnath ka mali aloo zara fike se pakata hai, copper, mercury, silver, gold, platinum. This is my song. My teacher told me to remember, and I am telling you. So just take it any way you can recall, you can make your own song. Just there is a need that you should remember this reactivity series because it plays an important role. As we did in the displacement reaction, that we come across, we know that what kind of displacement will occur or not just on the basis of reactivity series. Similarly, it plays an important role in the case of burning as well, because it shows, it actually proves us that which metal is going to react at room temperature, which is going to react at high temperature, and which is not going to react at all. So just look at the board, I am writing it for you. Potassium and sodium, being more reactive, will react at ordinary temperature. They will react at ordinary temperature, forming their oxides, right? Calcium and magnesium will obviously going to get oxidized, but when we will burn them, means the burning is required, we have to burn them in air, they will form their oxides. Similarly, the aluminium will form its oxide at ordinary temperature. Again, aluminium form its oxide at ordinary temperature. And when we talk about the zinc to mercury, they combine with oxygen at, you can say, when we burn them to a very high temperature. That means they are not so reactive towards the oxygen, but they do form their oxides, but when they form, when they are heated to a very high temperature. So when we heat them, they definitely form their oxides, but the condition required that they should be heated to a very high temperature. And when we talk about the silver, gold and platinum, they do not form their oxides at all, that because they are least reactive. So they do not react with oxygen even on very red when they are heated. When they are, you can say, when they are red hot also, they don't combine with oxygen to form their oxides. So this is how the metals react with this thing, the oxygen, they get oxidized at different temperatures. So you should have an idea that the potassium and sodium, being more reactive, will react at ordinary temperature. Calcium, magnesium will definitely react, but on burning is required. And aluminium, again, ordinary temperature. Zinc onwards, zinc to mercury, we need a high temperature. That means they have to be heated more. And silver, gold, platinum do not react at all, right? So these all metal oxides are actually basic in nature. That means when they are dissolved in water, they form the bases, strong bases, right? So now I am just listing the few examples for the non-metal as well, because there are not only the metals which get oxidized, there are non-metals also that gets oxidized. So like phosphorus, sulfur, carbon, almost all you can say the non-metals combine with oxygen to form their respective oxides. See, C plus O2, CO2, S plus O2, SO2, phosphorus plus oxygen, P2O5, phosphorus pentaoxide. Similarly, we do it for nitrogen and many more. The basic similarity between the non-metal oxides are that they are acidic in nature. They are acidic in nature. What do you mean by acidic? See, any substance behave as acid or base in the way that when we dissolve that oxide in water, if they form base, so that means the nature of that oxide is basic. And if any element oxide when dissolve in water form acid, it is said to be the nature is said to be an acidic oxide. So when we are talking about metals, generally all metals except the aluminium and the zinc one, all metal oxides are basic in nature, and most of the non-metal oxides, they do exist. The nature is neutral also, the nature is acidic also. We have neutral oxides as well, like CO and NO and all, they are neutral oxides. But the maximum non-metal oxides are acidic in nature. That means when they are added to the water, they form respective acids. So you should be clear with this phenomena that any metals and non-metals both are getting burned, they both can be oxidized in presence of air. The thing that matter is that there should be a combustible substance, there should be a presence of gas that can support combustion, and obviously an ignition temperature is required, because before that temperature any substance cannot catch fire. So it can catch fire only when the ignition temperature is achieved. So this is how I have told you what actually the burning is. So just keep in mind. And one more thing is striking in my mind. Look at the board or listen to me carefully. Whenever we are burning any substance, right? If I am taking any substance, suppose I have taken the magnesium ribbon and I am just burning it in the presence of oxygen. So you know it is going to form, I'll explain you with an activity. Just look at the board. we have this magnesium ribbon. Magnesium occurs in nature as magnesium ribbon, right? I am, with the help of tongs, I am just holding it. And then with the help of Bunsen burner, you know, it is a burner which is used in the lab to burn things. I am just burning this magnesium ribbon. So it is just getting burned, and in the form of ash-like compound, it is being collected in the china dish. I am using it. So what happens actually, if I wish to write a reaction, what happens? Magnesium ribbon combines with oxygen to form MgO, right? So this substance which is formed is MgO, magnesium oxide, right? And what is the characteristic actually of this reaction is, it produced white dazzling flame. It produced white dazzling flame. And what is the color of this compound? Obviously the color is white. It forms the white colored substance, that is MgO. And I want to know that the one thing which I wanted that you should know is that, see, when I took the magnesium ribbon, the weight of the magnesium ribbon was something else. Say I take as X, right? And after burning, when I get MgO, the weight is Y. So after burning, whenever you are burning anything, the weight of the product form is always greater than the weight of the reactant. So you should keep in mind that after burning, the weight actually increases. It doesn't decrease, it actually increases. Right. So this is the whole activity I've explained you. Just keep in mind, it's an important activity, this burning of magnesium ribbon. It comes under various topics. You'll be studying in various classes, various topics you'll be taking up in future. So just keep in mind, and these two properties are most important. White dazzling flame, that means whenever the magnesium ribbon is burned, it produces very beautiful, the white, silvery white dazzling flame. Right. So this is all we have done about burning. Now coming to the second aspect, we were taking a second example of chemical change, that is the respiration. Now the question comes, what is the respiration? Have you ever encountered respiration? I think it will be a foolish question to ask that have you ever encountered respiration? See, respiration forms an important part in our life. If we will not respire, we will not survive. Respiration is very, very, very important property of our human body. So just make you familiar with that important property. We are starting with the topic respiration. So what do you mean by respiration actually? Respiration is a process, listen to me carefully, because we often use word burning or, not burning, we often use word breathing and respiration as one thing. But breathing and respiration, both the terms are different from each other. Breathing forms a part of the respiration, but it is not actually the respiration, right? Respiration is a big process. It includes the breathing also. But breathing and respiration are two different terms. Respiration is a whole process comprising of many activities. Breathing is just an exchange of gases. So you'll be learning this, the difference between the breathing and the respiration in the bio part. But as far as the chemistry is concerned, we'll be taking up respiration, and we'll be just taking that how it acts as a chemical change and what is actually the difference between the burning and the respiration, as they both are chemical changes, but still they differ a lot from each other, right? So just look at the board. I'm explaining you what actually the respiration is. See, we take in oxygen, you know that. So respiration is intake of oxygen, right? Why we are taking up this oxygen? We are taking up this oxygen because we have the food in our body, like our cells have already absorbed the food. And why we take food? We need food for the energy, right? But the energy is not produced as such from the food. Certain process is required, and that process is called as respiration, right? So what are the three activities that respiration includes? First is the intake of oxygen, that is to inhale oxygen, right? Then use this oxygen for oxidation of food. That means this oxygen is used to break this food into the smaller particles, that as a result we get glucose, and plus we get energy and CO2. Instead of writing glucose, see, there are few processes like glucose, like the food contains glucose actually, you know, but glucose, when it gets oxidized, it gets converted to pyruvic acid, then pyruvic acid get converted to the energy in the form of chemical form of energy, that is ATP. But we won't be taking that in detail because it comes under the bio part, right? But still for for your easiness, I'm telling you, I'm just writing the reaction, so you can try to make it, you can try to understand if you get it. Otherwise we'll be doing in detail in the bio part. So what is the food? Food is actually in the form of glucose, right? It gets oxidized, and when it gets oxidized, when it gets broken up, it forms the, you can say, the simpler substances, that is, it forms the pyruvic acid, and then this pyruvic acid takes up the oxygen and it gets converted into the energy in the form of ATP. But this will be taking in bio part. So just for this movement, we need to have that the oxygen which we have taken will just oxidize the food. That means it will make the food broken into simpler ones, and along with that the energy will be produced, along with it CO2 will be produced, and some vapor will be there, right? And then this CO2 which is produced cannot remain in the body for longer period, so it has to be exhaled out. So exhaling or giving out CO2 is done then. So that means respiration involves 3 steps. 1, intake of oxygen. Why we are taking it? Because we need to oxidize the food which the cells have already absorbed, right? Second, again, the oxygen is used for the oxidation of food. That means, and what we get after the oxidation? We get the energy, CO2 and water vapor. Energy is in the form of ATP, adenosine triphosphate. Adenosine triphosphate, it is actually a chemical form of energy in which it is produced in a body, right? Then this CO2 cannot be retained in a body for longer period, it has to be exhaled out. So the exhaling of CO2 is the 3rd step. So that means respiration is all this, right? Again, it is a chemical change because it obeys all those characteristics which are mentioned by for the chemical change, that is the mass is changed, energy is absorbed or released, that we have already done in the physical and chemical change, and I think you are familiar with it. So just you should know that respiration is also an example of chemical change. Now the question lies that what is the difference between the burning and the respiration? See, in burning we are getting the substance oxidized, and similarly in the respiration we are getting the food oxidized. So where the difference lies? What is the actual difference between the respiration and the burning? So you should know, in burning we are oxidizing carbon, hydrogen, present in you can say any carbon compound, right? And in case of respiration, we are getting the again carbon and hydrogen oxidized present in the food material. This is the difference, right? It is just the oxidation of carbon and hydrogen which is present in a carbon compound, and it is the oxidation of carbon and hydrogen which is present in the food material. So this is the main difference between the respiration and the burning. And moreover, burning is a rapid process, it occurs very fast, but respiration is a slow process, right? So, and when we talk of the energy, so in case of burning, energy is liberated in form of heat and light. But in this case, we get the energy in the form of heat, that is in the form of ATP as a chemical energy and also as a heat, but we don't get light. Have you ever seen that you respire and you start sparking? No, we haven't seen. Because in burning, when the substance gets burned, it produces energy in the form of heat and light. But in the case of respiration, there is no light as such produced. Only the energy is produced, and the form is being the chemical form, that is ATP, adenosine triphosphate, and the other one is the heat. Heat can be produced as a byproduct after the respiration. So this we concluded that what actually the difference between the burning and the respiration is, and I hope that you have got it thoroughly. Just keep in mind, because whenever you are using few terms in a daily life, you should know that what actually they are, why we are using it, what difference is actually that exists between the two. And moreover, see, science, whenever we talk about the science, it is just a logical part. That is, we are running about the logic behind it. So just be well versed with the logic, and I just promise you that you'll love to learn the science, because the chemistry, bio and the physics, they they all are logical subjects, and I think learning the logic is something very different, and learning about your own human body or learning about all changes that are going around you is, I think, plays an important, interesting part. So just get into the logic whenever you are studying any subject. Just get into it, just get into the root of it, and you know, everything will seem to be very, very simple, and obviously it is going to be interesting, right?